Hi, this is Linear Algebra 1.2. We're going to deal with row reduction and echelon forms and reduced row echelon forms as well. So what we're trying to do is solve these systems of equations. And this is a little bit more methodical, and we'll see. So if I start here, we can solve a system of linear equations with a matrix. We'll do the same now, but we'll also introduce more terminology and also solve systems where there are more variables than equations. But just remember, if you get a false statement, there will never be a solution or no solution for that. Also, the steps that I'm going through here, you can freelance them a little bit. In the book, what they do is they go very, very methodically with the algorithm that they do have. So if you ever wanted to write a computer program, you're going to have to set out things in a very linear fashion or with that algorithm to sort things out. So just be cognizant of that. Yes, you can freelance a little bit when you're doing row reduced form of these. However, if you really wanted to program something, you have to be very, very methodical. So we have example 1 here. Row reduce the following matrix into echelon form. Do this using pivots. The book uses pivots. When I learned this, I didn't have pivots, but I think that it terminology that helps you set this up a little bit. And then we will try this also with a calculator. So get your calculator out and go to the matrix. I don't know why that was like that. Store the matrix in A. So what you're going to do is go to the menu and deal with the matrices, or else go to the other button that has all the other functions in it and set up a 4x5 matrix. Remember, we have 4 rows and then we're going to have 5 columns. So this would be a 4x5. And then put this in, and then you can store this, and the store is Control var just under the arrow pad. So you should have this set up right here. Okay, then what we want to do is we want to do reduced row echelon form. That's what RREF does. So you can either type this in or you can find this under the matrix menu. RREF of matrix A, since I did store this matrix into A. And this is what we get. Remember, we're solving this system of equations. So when I get this 1 right here, this would be of 4 variables. So this is x sub 4 is equal to 0. That's what that means right there. We'll talk a little bit more about what these other things mean in a second. So what we want to do is, by hand, get from here to here. So our goal a little bit is to get these values right here all to be zeros. If we do that, that would be echelon form. And then if I do get the 1s all leading like this in each one of the rows, then that would be reduced row echelon form, so that I can solve these things out quite readily. So looking at this matrix here, I want this 1 to be leading. So what I'm going to do is, since I have a 0 here already, I'm going to move that and exchange it with this 1 here. So I'm going to exchange row 1 and 4. And this is my augmented matrix that I do have. And so when I have this right here, this leading 1, you start at the top, leftmost position, and you call that your pivot. And try to get it to be a 1 if you can. And with that pivot, this right here becomes our pivot column. And with our pivot column, we want to ace out these 3 numbers and make them 0. And so that's what we're going to try to do. So we start leftmost and try to get this uppermost 1 to be a 1. And we call that the pivot. And then we're dealing with the pivot column. This will change as we move along. So I can fix this row right here and eliminate this -1 by just adding 1 and 2 together. So if I do that, I'm going to get a 0, I'm going to get a 2, I'm going to get 4, -9 plus 3, this is where I am, -9 plus 3 is going to give me -6, and then I'm going to end up with a -6 over here as well. So I just accomplished part of my goal in getting a 0 in that second row first column position. Now do the same with this one, and then this third one is already fixed. So I've done a nice job in getting these 3 values as zeros. That's our first goal. Now I want to try to get these two to be zeros. So what I'm going to use is I'm going to use this value right here, and now this is my new pivot. My pivot will slide over as I create these single numbers in a column with the rest being zeros. And so I'm going to take this 2 and try to eliminate these other two. So right now this is where you can start freelancing a little bit. This second row, all divisible by 2, and so then this term right here would become a 1 if I divide everything by 2. But let's try to multiply this row by -5/2 and then add it to this third row. If we do that, we're going to get a 0 right here. And then -5/2 times my 4 there is going to give me -10. So, oh, that gives me another 0. Okay. And then I take -5/2 times my -6 there. That would give me -3. Oh, that's what? Another 0. Oh, and another 0. So I'm going to get a 0 row. That doesn't always happen, but that did happen in this situation. Now to get this last one, I'm going to take a 2 and try to eliminate a -3. So I'm going to multiply the second row by 3/2 and then add it to the fourth row. So if I do that, I'm going to get 0. I'm going to get another 0. 3/2 times 4 would give me 2 times 3, which would give me 6. Oh, that gives me another 0. 3/2 times my -6 here would give me 6 divided by 2 is 3, so I'm going to get a -9. Add it to my 4, and I'm going to get a -5. And then 3/2 times this -6 also will give me a -9, plus the 9 is going to give me a 0. So if I switch the third and fourth rows around, I always want this 0 row to be at the end if I can. And so this right now is in echelon form because I have the requirement that I wanted is that all of these right here to be my zeros. Now finally, to get it in reduced row echelon form, I need this 2 to be a 1 and then this -5 to be a 1. So now remember that this is my goal right here. Doesn't quite look like that. I'm close. I got this one down. And in the other two rows, I have some other zeros in there. So what we did just now is what we call the forward phase. So this is the forward phase of my process. Now what I want to do though is I want to go ahead and take this value right here. And I want to eliminate anything above it that I can. And I'm going to take this 1 right here and eliminate anything above that as well. And so we're just going to kind of clear out what's above it, and then that should give me my zeros here and my 0 there. So let's try this and see how this works. So in my backward phase, none of these red numbers are going to change that I have over here in this matrix. But what I'm going to do now is I'm going to try to eliminate this 4, not necessarily that 5, and then this -9 using this one right here. So let's work on this 4 first. What I'm going to do is I'm going to take this row right here and I'm going to multiply by -4 and then add it to row 1. And so when I do that, I still get this first 1 right here, and then I'm going to get a 0 here, that's what I want. And then if I take this -4 and multiply it by 2, I'm going to get -8, and then I'm going to add it to this 5, and I'm going to get a 3. Sorry, -3. And then I keep on going. -4 times this is 12, and add it to this 9, -9, I'm going to get a 3. And let me put those numbers in black because those are the ones that I'm changing. Then I'm going to take this -4 and multiply it by this -3, and I'm going to get 12, and add it to 5. I'm sorry, add it to -7, I'm going to get 5. And I'm going to do this in one more step, but I'm going to change this -3 and this -3 as well, possibly, but I'm going to use this 1 in order to do that. So my last goal here is to go ahead and take this 1 right here and eliminate everything above it. This is the backwards phase. So I'm going to multiply by 3 in order to eliminate this one, and I'm going to multiply by -3 times this 1 to eliminate this one. So that's going to be kind of 2-row process for me in order to do that. So if I take row 3 and I multiply by -3, then I can add to this row right here in order to eliminate this 3 right there. So I'm still going to get my 0, -3, but now this is going to be eliminated, so that's going to be a 0. And then if I take this -3 times this 0 and add it to my 5, I'm still going to get my 5. So that doesn't show the full effect of what's going on there, but because it's 0, but that's what's happening. Then if I want to eliminate this one here, I'm going to multiply by +3 and then add to that row. These two numbers stay the same. Actually, these three numbers stay the same. And so then I get 3 times 1. That's going to give me my 0. And then 3 times 0 here added in is still going to give me -3. So that's the result that I'm going to end up with. And then this would be my reduced row echelon form. And how did we do compared to our calculator? All right, we did the same thing. We ended up in the same exact spot. Fantastic. And if we do reduce row echelon form with these steps, put the 0 row at the end and all that kind of stuff, everybody's going to get the same answer. It's going to turn out the same. So there's a uniqueness theorem with this that tells me that this result is going to be unique for whatever system I do have. Now the question is what's my solution? Well, if I look at this situation right here, wow, I have a variable, the x3, that I can call x2 in terms of and x1 in terms of. And so what we're going to do is we're going to call this x3, we're going to call it free. So if I put this in order as a solution, we know that x4 is equal to 0. x3 is going to be equal to a free variable. You can choose whatever you want. And so this is going to lead to an infinite number of solutions. Now what is x2? I'm going to run out of room here, so I'll put it over here. But x2 is going to be equal to -2x3 minus 3. And then what's x1? x1 is going to be equal to, from here, it's going to be equal to 3x3 plus 5. And so since this says free right here, you are going to have an infinite number of solutions because you can choose anything for x3 that you want. So this would be infinitely many. Infinite solutions, and it's consistent because you will have a solution. The only time we'll be inconsistent is if we get like 0 is equal to 5. That doesn't work. So that would be inconsistent then. Okay? So this is what we're doing right here, and then this is how we would write our solution right here, even though I'm running out of room. Sorry about that. So here's how we define all this stuff. Rectangular matrix echelon form if it has the following 3 properties. The first one is all non-zero rows are above any rows of all zeros, so put all your 0 rows at the bottom. The second one is each leading entry of a row is in a column to the right of a leading entry of the row above it. So that means that I have this 1 here, and so my next row is going to have the 1 that's 1 over. And then, and it doesn't necessarily need to be a 1 if it's echelon form. All entries in a column below a leading entry are zeros. So here, leading entry, I have all zeros. I have all zeros, and so on. And then if we want reduced row echelon form, then the leading entry of each one is going to be a 1. And then this one here, each leading one is the only non-zero entry in its column. And so we have a 1 here, non-zero below it, non-zero below this 1. And this is a 1, and that's a 0 below it. So that would be reduced row echelon form. The uniqueness is that if I solve for it, everybody should get the same 1. Okay? This is getting a little long. I apologize. I still have another example to go. Okay, this one, example number 2, you're going to do exactly what we just did. But I would encourage you to go put it into your calculator and see what you're going to end up with. That doesn't mean that you're going to fight to get that solution, but that is what you're going to be looking at for a solution. So you get a picture of where you're going. And then do the steps in order to figure it out. I'm going to do it out here, but I highly recommend you just go do it. Pause this, and then work it out and see if you can get the solution that you did get off your calculator. So for me, if I'm going to do this, I'm going to switch rows 1 and 2 because I want the start to not have a 0. And I'm going to change that. Look at this third row. Third row is all divisible by 3. If I divide everything by 3, then I can get the 1 in the upper left-hand corner straight away. So I'm going to axe that first idea and go ahead with that idea that I do have now. So one of my first goals is to get this to be my pivot, and so I'm going to eliminate everything below it. I already got one thing eliminated, so I just need to eliminate this 3. So I'm going to multiply the first row by -3 and add. So now I get this, and look at this row. Everything's divisible by 2, so maybe I'll put that in the second column with everything with a leading coefficient here of 1. Now I can go eliminate this one right here by using this 1 right here. So I'm going to multiply this one by -3 and then add it to this row right here and place it at the end. Skipping a couple steps there. I hope you can follow. It looks like I made a mistake right here. That should be a -4. So then this number would change. So that's what I get for this step. Nice, I got this one right here. I could go solve and back substitute, but I want to do this our new way by doing the backwards phase. Notice that I have a 1, and then I have zeros below it. I have a 1 and then a 0 below it. And then here, yeah, I don't have a 1 there, but it's already all the way in here, so I'm okay. Now I can go do the backwards phase and take this 1 and eliminate these two right here. That's what I'm going to do. And also I'm going to take this 1 and eliminate this -3 here. And it's just like Algebra 1. If you try to do too many steps into one, you're going to make mistakes. So I got to be careful here. So what I did was I took this 1 right here and I eliminated this value, so I got down to 0. Now I want to go ahead and take this value right here and then eliminate these two right here. So these are going to be the only values, these blanks here that I have are going to be the only values I'm going to change. So if you put this into your calculator, this is exactly what you did get. Now with this last step, I wanted to eliminate this 1 here. I could multiply this row right here by a -1 and then add, or I could have multiplied this by -1 and added. However, if I would have multiplied this row by -1, that would have changed this value, and I don't want that. I want it to keep it as a 1. So that's what I did in order to figure that out. So this is what we ended up with. Then we write out our solution. So finally, what does this all mean? Well, this means that my x5 right here is going to be equal to 4. And then if I go up to these other statements, this is the equivalent statement for this row in the augmented matrix. This statement right here is equivalent to this one right here. So if I go ahead and solve for x1, I'm going to get this right here. It's going to be the opposite of that, opposite of that. This one stays the same because my equal sign is considered to be right there. And then my x sub 2, I can get from this equation right here. And so I'm going to solve and I'm going to get a positive 2x sub 3 minus 2x sub 4, and then it's equal to -7, so that's already over on that side, so that's why I get my -7 there. x3, x4 are free, and so this one would have an infinitely many solutions because you could pick anything that you want for x3 and x4 and plug it in and figure things out from there. Okay, so that's what we end up with for this. And I got one last statement at the bottom. Let's see what that says. So this says that we started with the forward phase and then we use the backward phase in our process. This is the forward phase, and then this is the backward phase in the blue. And then theorem 2. And theorem 2 is pretty important here, but it does say that the system is consistent when the solution set contains either a unique solution, so you're going to get straight values, 2, -5, 7, whatever, when there are no free variables. But if we do have free variables, then it's going to be infinitely many solutions when there is at least one free variable. Before we said that we get infinitely many if we get 0 equal to 0 or 4 equal to 4, solutions like that. Well, that frees up one of our variables when we do solve. And so that's what's happening, is that we do get a free variable when this thing right here happens, or you just have more equations than you, more variables than you do equations. or you get many 0 rows because that will create that same situation too. All right, so we have that for 1.2. I hope you enjoyed this. Sorry for the length, and I hope you have a great day.